I get 6.02 times 10 to the 23rd power problem, but a mole ain't one. This may be a joke, but true enough, 6.02 times 10 to the 23rd power is equal to 1 mole. Good day, Batang IS! Today's lesson will enlighten us who is behind that number that is equivalent to 1 mole. The principles that, under the same temperature and pressure, equal volumes of gases will contain equal numbers of molecules, first put forth by Avogadro in 1811, but not accepted until 1858 when Stanislao Cannizzaro created a logical system of chemistry based on it. In the previous lesson, the Italian chemist Lorenzo Romano Amedeo Carlo Avogadro was mentioned, specifically the Avogadro's number. He found out in his experiment the relationship between the volume and the number of moles of gas. He proposed his hypothesis regarding the amount of gas expressed in the number of its moles to the volume of a gas. The hypothesis is now known as Avogadro's Law, which states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. Volume is the amount of space occupied by gas molecules, while mole is a unit to represent the amount of gas or number of particles contained in a substance. Remember that 1 mole is equivalent to 6.02 times 10 to the 23rd power particles. At a standard temperature and pressure, 6.02 times 10 to the 23rd power particles of gas occupy a volume of 22.4 liters, which means that 1 mole of any gas occupies a volume of 22.4 liters. The balloons all have the same volume. This means that they all contain the same number of molecules. Mathematically, Avogadro's law is expressed as V is directly proportional to N at constant pressure and temperature, where V is the volume and N is the number of molecules. The two different gases with the same volume at the same temperature and pressure contain an equal number of molecules. Mathematically, this can be expressed as V sub 1 over N sub 1 is equal to V sub 2 over N sub 2. Thus, V sub 1 times N sub 2 is equal to V sub 2 times N sub 1. Since V sub 1 times N sub 1 is equal to V sub 2 times N sub 1, we can derive the following formula. In solving for the initial volume, we use the formula V sub 1 is equal to V sub 2 times N sub 1 all over N sub 2. In solving for the final volume, we use the formula V sub 2 is equal to V sub 1 times N sub 2 all over N sub 1. In solving for the initial number of molecules, we use the formula N sub 1 is equal to V sub 1 times N sub 2 all over V sub 2. And in solving for the final number of molecules, we use the formula N sub 2 is equal to V sub 2 times N sub 1 all over V sub 1. This is the schematic illustration of Avogadro's law. The volume of a gas is directly related to the number of moles of gas. Increasing the moles of gas at constant pressure means more volume is needed to hold the gas. Since we already know the different formula that we can use, let us apply the Avogadro's law in solving the following problems. Sample problem number 1. If 0.105 moles of helium gas occupies a volume of 2.35 liters at a certain temperature and pressure, what volume would 0.337 moles of helium occupy under the same conditions? So these are the given. We have N sub 1 is equal to 0.105 mole. V sub 1 is equal to 2.35 liters. N sub 2 is equal to 0.337 mole. And we're looking for the final volume. So we are going to use the formula V sub 2 is equal to V sub 1 times N sub 2 all over N sub 1. So that is equivalent to 2.35 liters times 0.337 mole all over 0.105 mole. We're going to cancel the unit mole. Multiply 2.35 to 0.337 and divide the answer by 0.105. And the answer is 7.54 liters. So the final volume is 7.54 liters.
Sample problem number 2. 5 liters of a gas is known to contain 0.965 mole. If the amount of gas is increased to 1.80 moles, what new volume will result?
So these are the given. We have N sub 1 is equal to 0.965 mole. V sub 1 is equal to 5 liters. N sub 2 is equal to 1.80 mole. And we're looking for the final volume. So we are going to use the formula V sub 2 is equal to V sub 1 times N sub 2 all over N sub 1. So that is equivalent to 5 liters times 1.80 mole all over 0.965 mole. So we are going to cancel the unit mole. Multiply 5 to 1.8 and divide the answer by 0.965. And the answer is 9.33 liters. Our final volume is 9.33 liters.
Avogadro's law explains the following phenomena or applications. A flat tire takes up less volume than an inflated tire. As you inhale, your lungs expand as they filled with air. As you exhale, your lungs decrease in volume. A helium-filled balloon weighs much less than an identical balloon filled with air. So there you have it, Batang IS. Thank you for watching the video. I hope that you have learned something that you can apply in your daily life. Shout out to Jene, Yumi, Nobi, Iya, Francia, Joff, and Av. God bless, Batang IS.